So in this video, what we're going to do is we're going to figure out the equation of a parabola using not only the x-intercepts, but a totally different point. So let's do that with an example. So right here, a parabola has the x-intercepts -1 and 7 and a y-intercept of 14. Find the vertical stretch. So a good idea, if you're confused and you have no idea what they're talking about, is just draw a sketch. Let's draw a quick sketch. So we have that right there, that's our y-axis, that's our x-axis, and what we have is a y-intercept of -1, and sorry, an x-intercept of -1, and another x-intercept of 7, and then here we're given a y-intercept of 14, so which means that's basically 14. So how would we draw a quick, and we know that our axis of symmetry is going to be halfway between -1 and 7, and halfway, let's actually just do that. So if we want to find the axis of symmetry, it's going to be -1 plus 7 divided by 2. Remember, it's halfway, p plus q divided by 2. So it's 6 divided by 2, which is equal to 3. So we know that our axis of symmetry is going to be somewhere over there, and that's going to be x equals 3. So if I had to sort of connect the dots, I don't know where my vertex is, but I know it's going to be somewhere on this line, and it's going to be fixed because I have a fixed point of 14 right there. So it's going to go something like this. It's going to have a maximum right there and go down like that, and that's basically going to be my parabola. So there's going to be a specific a value. So in the previous slide that we saw, the previous video, let me just go to the previous video, we had multiple stretches. So we had basically many parabolas that went through the same x-intercepts, but we could have multiple of them. In this case, we have a very specific one because we have another point. If we have 14 over here, this shape cannot change because it's fixed. So we have to figure out what a value will create this shape. So how do we do that? Well, since we have the x-intercepts, we can figure out what, we can write this in factored form. So we have y is equal to a, x plus 1, because it's -1 here, so it's going to be the opposite here, plus 1. And since this is 7, it's going to be x minus 7. All right, so we have these 2 points, the x-intercepts, and we determined we cannot use the x-intercepts to determine what the vertical stretch is. So we need another point. So here in this case, we have the y-intercept. So the y-intercept is 14. And if you recall, when we have a y-intercept, it just means the x value is 0. So if I had to write this as a coordinate, the x value is 0, and the y-intercept is 14, so the y value must be 14. So here's the coordinate of the y-intercept. Now what I'm going to do is I'm going to plug this this coordinate right into this equation, and that's going to help me find a. So let's do that. So y is equal to 14, so this is equal to 14, which is a. X is 0, as we saw over here, so 0 plus 1, and this is 0 minus 7. So this is 14 is equal to a times 1 times -7. So 14 is equal to -7a, because a times 1 is a, and that times -7 is -7a. So finally, a is equal to 14 divided by -7, which is equal to -2. So our vertical stretch is basically a value of 2, but the negative here tells me that there's a reflection over the x-axis, and that makes sense because this is facing down, so there's a reflection over the x-axis. So finally, if I want, now I didn't put this in the question, but if I had to write this in factored form, I would write y equals -2, x plus 1, and x minus 7, and this is how you would write this very equation. That's how you would write that in factored form. All right, so that's how we sort of solve this using one other point. In this case, it was the y-intercept. Now, is it necessary that we only have the y-intercept? Can any other point do other than the x-intercepts? Of course, and that's what we'll investigate in the next video. So see you in the next video.